Good morning, everybody. I'm Olaf. I work at Falcon Force. I used to be a documentary photographer, so I like images a lot. There might be some in here, not that many as usual, but try to be as condensed as possible. And of course, I like warm hugs, right? If you want to see more, at the end, there's still some links, but I have a lot of content to go through. So just to set the scene a little bit, we do a lot of detection engineering. Of course, that's also in the title. And we developed a sort of cycle that we use to iterate over our development process. So we start with a hypothesis, right? We need to do something. We want to build a detection. It can be either we found an attack technique that we want to cover, or we found a new way in the red team that we can execute something in a way that isn't detected out of the box. So we need to build a detection for that. So then we go into my favorite phase, is investigation and research. So we figure out how is this attack executed? Can we find source code online? Can we find samples? Can we replicate this? We run this in a lab environment that is set up like a small enterprise, so that we can see like what would it look like if it is logged. And from there on out, we have telemetry, right? We generated all kinds of stuff. We understand the attack, which is crucial here. I can read a report and then try to build a detection, but then I still don't know what happens. I need to know what the attacker sees, how he operates, and these kinds of things, and that's very important. And from there, we can start building a detection, right? So in the lab, we can filter through our logs, filter it down to a point where we think we have a good detection. But then we're not done yet, because a lab, of course, is not like production. For people that have tried, you'll see that there's a difference, right? So we'll bring it to production, we reanalyze the results. Sometimes we have to go back to our development cycle, or maybe even back to the research cycle, because it's too noisy, too many false positives, or all kinds of reasons where we can't implement it yet. But if all goes well, we can. And then we move on to our reporting phase, where we write the documentation, maybe we update some heat maps or these kinds of things. And we plan our maintenance. And this is also something that a lot of people forget, but maintaining your rules is crucial. Again, stuff breaks, logs change, all kinds of reasons why your detection is failing. So definitely keep that in mind, right? So from a simplified idea, again, so we come up with an idea, we put it on a backlog just to be efficient. Then we go through it in a group, we plan it, and then we start doing the research. Sometimes we immediately abandon it because I already looked at it, or one of my colleagues looked at it. It's like, yeah, there's no logs for that, skip it. And then we go into the R&D phase that I just explained. From there, we can still go back to the abandonment, right? There's no logs, or there's no viable way of detecting it. Sometimes we know that either Microsoft or some other product that we're working on is working on telemetry. So then we know it's coming up, but we don't have it yet. Or sometimes we have preview features that aren't in the real products yet. So then we put it in block mode until it's released in the public side. And then we, at some point, put it back on the backlog, finish it, and then put it on to production. Before we go to production, there's first a review mode, because I can create stuff and be very proud of it, but my colleague needs to agree. So usually it goes into review mode, they go through it. Since I replicated the attacks in the lab, they can also see the results of my detection, right? Like, what are you detecting? Does that make sense? Is your logic sound? And these kinds of things. And in most cases, that's good. Sometimes there's comments, right? So then I need to refine some stuff, improve things, all kinds of reasons to make it better. And then in the end, of course, it's fine, it's done, and then we can deploy it. And again, we plan our maintenance, right? And then sometimes we have to do some research again, because, I don't know, there may be a better way of doing the technique, or better way of writing the detection. So from there, we can start doing a lot more. And this is all the happy flow, right? Everything goes well. Sometimes life has different ideas, right? So it takes a while maybe to see what's happening, but things hurt. So people learn in different ways. So do I. So one of them is experience. So you just do something and you learn from what you did. Sometimes it's reflection, right? Like you did something in the past, or you've seen something and you think about it, it's like, hey, how can I improve? What can I learn from this? And that can be an iterative process as well. Can also be repetition. Like, we've all been to school, we had to learn like rows of text and all kinds of words in foreign languages, all these kinds of things. And then at some point they stick. or not. Observation can be one, right? We all watch YouTube, or we, I don't know, watch a talk, I guess. So that can also be another one. Or receiving education. So you go to a training, you go to a class, you attend a nice course, whatever. It was also funny when I put this in a row, I saw that it spelled error. It was kind of unintentional, but funny. So from there, that's also how I learn. So I usually start with doing something. I'm not the guy that reads the manual first, even though I sometimes should. So I try and fail a lot and then keep on doing that. So that's where the repetition comes in, right? So I keep on failing, hopefully till it works or till I understand it. So if it works, yay, I'm happy. But quite often it's like, hey, I need help. I need some other means of support. So either I check a colleague, or I read a blog first, usually. I try not to bother people if I don't have to, find a YouTube video if I can, but sometimes it's not there. And I work with a lot of smart guys that can usually get me out of a pinch, right? So then I can move on. Sometimes I still need to find some things, so I use the Windows internals book sometimes, but they're not the nicest to read. So there's all kinds of ways to find a solution. Sometimes there isn't, but usually it's just keep on trying till you get there, or at some point think, okay, tried enough, let's abandon it. So it's a weird process, and it's probably different for everybody else. So making it a little bit more tangible, there's all kinds of research challenges that we get when we're doing detection engineering, right? There can be assumptions that are different in reality. So one of the ones is this should never happen in production, right? We say that quite often. Ironically, it does. So you can learn a lot from that just by challenging your assumptions. The same with you find something in the source code that looks like, hey, this is something that is very unique. I'm going to build a detection for that. Sometimes you're right, sometimes you're not. Could also be the other way around, where we come up with all kinds of attack scenarios that we know are abusable, and then turns out that an attacker usually just goes for this one scenario, and all the other ones you've researched and built detections for will never be triggered because the path is way easier that way. Is it wrong? No, probably not, because at some point it might actually happen, but you spend quite a lot of time doing something that could also be spent on something else. This is something that we encounter quite a lot. So you have a great way of replicating an attack, then you start looking at the logs and it's like, nothing. Or also in the Intune example, it's like you replicate the whole attack, and then it's like you get one line that says something happened, basically. And then it's good luck finding whatever happened. So it's very, very frustrating. Another one is where the telemetry can be incomplete. So you're replicating a behavior and you can't consistently see that in the logs, or you're missing like spots of it, which is also very annoying. This is especially a thing when you're working with an EDR, because they need to balance all the telemetry that goes into the cloud for bandwidth, preservation, performance reasons, and of course, cost savings, which is probably one of the bigger ones. And there's another one where logs can be somewhat unreliable. Also, if you're building your own baselines, it can be very tricky if you're doing research, because at some point you're tainting your own baseline, and then your detection doesn't work anymore. And sometimes it takes a while to figure out that it's sort of your own fault because you poisoned the well. And since we can't go into all of them, I selected a couple, and hopefully we have plenty of time to go through those. So the first one is so no process should read the else as memory, right? That's a valid assumption, we thought. So we started looking into it, and we wrote a very simple query. Defender for Endpoint has an action type that tells you reprocess memory API call. And it only logs that for else says, so that's in this case convenient. So we can look at if that happened. And we looked at it in an environment with 62K endpoints. And it happened a couple of times, right? It's like 64 million times in 30 days. So it definitely happens. So at some point we started looking into, okay, which processes are doing that? So we just refined the query a little bit, looking at which processes are doing it. And there were 230 or 213 processes, unique processes that are doing it in the same time frame. So again, super common. Also funny that at some point I saw one of the Realtek processes doing this, and that brought back some research that my colleague Henry, that's sitting in the front, did, where at some point we found out that one of the other Realtek services was calling open process with the read process memory API on LSAS. And it did it with all permissions, basically. It's like, okay, I want just full access because an audio driver needs that, right? And it sort of happened only when certain DLLs were loaded by processes. And at some point he figured out that it was a sort of unintended side effect of enumerating which DLLs are loaded so that the audio driver knows that they need to hook it and provide some audio. Of course, LSAS doesn't do audio, as far as I know. So they reported it and it was solved for that driver, but now there's a new one that apparently still has that. And I think it was, at some point you figured out there was like a bit of Stack Overflow code that looked the same. So people do weird shit. So at some point we figured out, okay, this is not a good thing. Let's look at if we can refine that a little bit. So at some point we figured out that we can also see how much memory is actually read. I'm not sure if every EDR does that, but at least Defender for Endpoint shows you how much memory is there. And that would be a better way of detecting it, right? If somebody reads like the full memory of LSAS, that is more likely that probably they're trying to dump credentials. So we still had a couple of really weird processes like display link hotdeck service and some other like Macrium service, which was a video game. So there's still like all these big brands that are just greedily just hosing down LSAS memory. And they're usually exempted by the EDR because they're so noisy, right? So if you're an attacker, just figure out some of the ones that I just showed you, name your process that way, dump LSAS, and it's most likely that you won't be blocked. So pretty sad. So some lessons that I learned here is like validate your assumptions. Not everything that looks bad is bad. There's a lot of poor software development practice, which is okay if you're building a tool for yourself, maybe, but like production software should be better. But this is very common, right? You'll see that if you're doing a lot of detection engineering, there's a lot of weird stuff that shouldn't look like it does. But also understanding what kind of logs are there, right? After a while, we figured out, hey, we can also see how much memory is being read. So just going through every log that you have can actually still end up with a valuable detection. So it's only a partial fail. And we also learned that like some of these logs are only applied to a very niche set of things. So for the read process memory, only LSAS is logged. So if you dump the memory of another process, you won't see it in Defender at least. On the next topic, so this looks like an IOC. Let's build a detection. Everybody's heard of Kerberoasting, right? Tim Medine is doing a thing downstairs even. So there's plenty of tools that you can use to dump or to get a Kerberos ticket or service ticket out. Yeah, that's a nice thing. Squirrel. So there's plenty of tools that you can use and research. And most of them are open source, which is great. But there's a lot of implementations, but most of them are based out of these ones. So at some point, as you do, you go through GitHub, look at the source code, and I found this line here where it says like datetime from Kakeo, high 2037, and then you see this hard-coded timestamp of the end time of the ticket service ticket request. So I went through GitHub a little bit more to only look for that string, and I found like all kinds of other tools that also use that same hard-coded string in there. So I figured this might be something. So again, I work a lot with Defender for Endpoint, as you might have noticed. They also ported Zeek, I think like a year or something ago, a year and a half. And they do have some nice Zeek events. So the one that my eye fell on was the TGS request, where you also get a sample of the packet that is being exchanged, which is over there. And the thing there was it's URL encoded. So it's not the easiest to read. Kusto does have a KQL decoder, but that turned out to fail because it only works if it is a string that only has ASCII characters in there. If there's any other non-ASCII characters in there, it just does nothing. So it doesn't decode anything. So that was a disappointment. Fortunately, there's tools like CyberChef. They do that as well, and they actually can decode it. So at some point, all the way at the bottom, right there was that timestamp. So it's like, hey, this is cool. Maybe I can do something with this. So later, I also went back to the top view, basically this part, like my inputs in the packet, and it's already just there, just in plain text. So I started playing with that a little bit more, extracted it with some fun regex, and now I had a time stamp in my column set, so I can actually refine a query for that. So usually a TGS request in the production environment, what we saw was some range between 10 hours and 30 days, where 30 was already on the high end. We even saw some 90 days, but that was about it. So I figured, okay, let's build a detection. If it exceeds 30 days, that's suspicious, I want to see it. So that sounds simple, and it was. So I built a detection for that in the lab, worked great, happy. Then I went to a client environment, and this happened. So, and this was, I think, over 24 hours. So it was crazy. A lot of things. And this is a 70K endpoint client, so it was fairly sizable. So I was not happy. So then I was like, why do people use this? So I started looking a little bit. The Unix timestamp is 32 bits. And the end of that is somewhere 2038. So that's maybe the new, what is it, Y2K thing. And sort of assumption-based, I figured, okay, maybe they want to have an infinite expiry and they just don't want to put it at that 2038 bit. So they put it a little bit earlier. So it was 128 days, but also some weird minutes and seconds, which I didn't understand. The 128 days makes sense, right? It's sort of a nice iteration. So I reached out to Steve Cyphers, who was at that point, I think, part of the Kerberos implementation on Windows. He had a similar explanation as I assumed, but also he couldn't really memorize it anymore. And it was primarily for like compatibility with Linux. And later out, I also found the 2003 source code of Windows that leaked at some point, and it's even hard-coded in there as an example. So at some point, now for Windows 11, you see that like this 99999, so it's like even weirder timestamp that they put in it. So in the end, no detection. Until I reached out to Henry, and he helped me actually decode the full packets, and we basically decoded ASM1 packets with Kusto, which was interesting. And there's a whole write-up for it. So if you're interested in when it actually turned into a success and then failed because Microsoft failed at that event after all that work. So that was sad. Yeah, I learned a lot of new regex tricks, which I already forgot. Sometimes there are actually intentional IOCs. There's plenty of Red Team tool developers that put in IOCs that are super useful for detection engineers. Sometimes they're unintentional, which is also it's even more useful because then we can still leverage those, and most of the offensive people that recompile the code won't change them. But sometimes it's also just a weird example that at some point was released in 2003, and then people just use that because it's an example and they don't change it. And then, yeah, even sometimes for detecting this behavior, there's a way easier way. Right? You can just look at the directory logs, parse the ticket options, and then get it out. But sometimes it's actually cool also to try to solve a hard problem, and it's better if you succeed, but you can still fail. And maybe what I learned, at least personally, is reading through source code is super useful if you have it available, so that you can understand what's going on, what is actually done. And also in the Kerberos example, there you can see which ticket options they're setting, right? So there's actually some behavior that you can already derive from looking at the code without running it. So that's super valuable. logs. Logs can be, they're super important, but they can be super incomplete as well. Again, especially if you're working with EDRs. If you do the research, you usually don't do it once, right? You're iterating, you're sometimes even fiddling with all kinds of command line options. If you looked at Wietz's talk yesterday, there's all kinds of ways where an attacker can try to change the behavior slightly to circumvent some detections. So in this case, with the previous example, I ran it like 30 times to see if I could generate different ticket options and get some different results. Then I started looking at Defender for Endpoint for the same data set, same machine, same time frame, and I got 14. It's like, that's strange. I have Sysmon on the same machine, and that's all 30. So that's like, that's okay. Then I started looking at the network connections. There was 1. Whereas Sysmon saw the same events 30 times. So it's sort of how I felt, not really, but this is the more polite version. But it's like, what the F, right? It's strange. So at some point, we figured out we could read the configuration of Defender for Endpoint. And going through that, there is a filter for a lot of things. So this is part of the ETW feed that they hook onto for the TCP flow. And basically what you're seeing is we're looking at the connection accepted one. And then we can see that there is a local cap, which is set to a period of 24 hours, where it's capped to one event, where the first seen instance of that whole set of variables is there. So if these fields are identical for 30 times, which I did, because I ran the process 30 times, I connected to the same IP, I connected from the same IP to the same port, you get 1. There's all kinds of opinions to have on that, but this is what we have to work with, right? So it's very confusing sometimes if you're testing a lot of things in the same lab within a short time frame, then you might actually cause blind spots for yourself. And even if you know about this can still be limiting sometimes, because if you're trying to correlate multiple events in a row, then it breaks because you're looking at a specific time frame and these kinds of things. So it's quite annoying. And this applies to everything in Defender for Endpoint, but this also applies to CrowdStrike and a lot of the other vendors, right? This is very common practice because otherwise they're ingesting gigabytes a day and you pay $20. So it's a price thing, but also a performance thing. You're just flooding the bandwidth of every machine or every computer. So this is something to be aware of. Additionally, logs can also be filtered because sometimes they don't want you to see stuff that is very common or very repetitive next to the capping. So in this example, we at some point accidentally found this out, but we have AD Explorer, which most people have heard about, right? It's a nice sysadmin tool that can also be used for offensive operations. And sysinternals releases this in 3 versions. So there's a 32-bit, a 64-bit, and a 64-bit ARM version for all kinds of useful features. So I did the same thing. I ran all 3 of them on the same machine, connected to the same domain. Nothing fancy there. And I looked at the process execution logs. And this is already interesting, where you can see that the 32-bit version also contains the 64-bit version. So it first unpacks the 64-bit version and then runs that. So that's why you see like double executions for the first one. But you also see the 64-bit and the ARM version just starting up. So that's fine. Nothing special there. What AD Explorer does, it makes an LDAP connection to the domain controller, because otherwise you can't talk to AD, right? So Defender also logs LDAP search events, but now we only see the 64-bit and the 64-bit ARM version. Where's the 32-bit? It's like, again, yes, there's another config. So what they also do here, next to the local capping, which you can see is you like per search filter and distinguished name, they cap that down, so that if you constantly keep on doing the same searches, you only get 1 event, which is fine. That's not a big problem. The bigger problem comes when we look at the filters. So there's also a filter where it says a not. And then if the end clause of the initiating process or the original file name of the original file name of the initiating process is adexplore.exe. I don't know why they filter that one and not the other two, or the other way around, why they filter it at all, because it's kind of useful information to have as a detection engineer. But yeah, know this, right? So you're partially blind, and this is also useful if you're an attacker, just use 32-bit version. People don't see you doing LDAP queries. So again, scrutinize the tools that you rely on. So I showed now all kinds of Defender for Endpoint things, but every tool has its quirks, right? If you're using CrowdStrike, they'll have other issues, and maybe they fix this, but there's something else. So you know your blind spots. That's basically the bottom line of it. And what you see in the tool might not be everything, right? As we just established, there might be things that are intentionally filtered for all kinds of reasons. So test, validate, and repeat, so that you can also prove whatever your assumption is. Not everybody figured out to read a config or whatever. Sometimes it's actually impossible to do that. So then you have to test it and prove your assumptions a little bit more. But at least, yeah, by doing this, you know your tool, right? So you know what you can rely on, what you can't rely on. Last one is consistency. This is also a fun one. So different versions of a product may send logs in a different way, right? We all have had Palo Alto firewalls or Junipers, whatever. Every time they do a firmware upgrade, the log format might shift a bit. So that's a simple one. But even within Windows, there's weird quirks. So the same event may look different across the same machine, but also across all your machines. And cloud solutions are even worse. They can just change their log schema. They'll probably inform someone somewhere, but nobody knows that, right? So it's at some point your logs look different, and you're like, hey. So funny thing is casing. So these three events I showed you earlier with AD Explorer, you can see on the left side, you see the process execution, so the device process events, where the process started. And we can see, like AD Explorer, also what it was named on the file system. So uppercase ADE, and then the rest lowercase, and the same for the path. But if we look at the LDAP search event, we can see that everything is lowercase here. I think I zoomed out. So, and oddly enough, even for the same machine, it's sometimes even within the same event, it's the same. So here we can see LDAP searches for AD Explorer, and we see them in both casing, even from the same device. So, and then the path is both lowercase. So there's like all kinds of mixes going around. Why? I really don't know. Partially because they get data from different providers, right? Some is kernel extensions, or kernel callbacks, sorry. Some is ETW, some is trace logs. But this is the same event. So that's, I really don't know how to explain that. But you have to take this into account. So why does this matter? What we see a lot when people are building queries is they're using the double equal sign, which in Custo means a string, a case-sensitive string match. And that becomes a problem, right? Because if you have two different casings, the string doesn't match. So I started looking at GitHub this morning because I was jet lagged. And I just went through the rules that Microsoft publishes as examples or as rules that you can implement. And there were like, almost 80 rules where they had an instance of fixed file name or a fixed folder path. In some cases, you see that they do apply it well with like the case sensitive match, but in most cases there was a case sensitive match. And it was also in all kinds of other examples that I found online where they're doing like fixed casing string matches, which is super dangerous. I mean, it works in your lab, probably at the instance that you did it. But if you run this in a different environment or 10 minutes later, the casing might be different and then you actually have a blind spot. So the best practice from Microsoft is to do this also in their documentation because it is more performant, but you will get blind spots. So case sensitivity is a huge thing. It's even worse if you're trying to do a join. So if you're doing two tables and you're matching these events, the join is always case sensitive. So you need to do like a weird fix where you have to either upper or lower case the join keys, because otherwise you will just not see the correlation and you think nothing happened, but you're basically filtering it out. So that's a huge problem. Last one, these are two different Azure tenants. So this is our research tenant and our prod tenant. We're looking at the same event, where on one end we can see that the value here is like in mixed case, and on the other end it's full uppercase. Why? I don't know. This is again something weirdly random, especially in Azure you see this a lot, where the casing is different. And for the people that are very keen-eyed, you can also see that they at some point changed the schema, where here it's called activity status, and here it's called activity status value. Same event, different fields, and also the values are different, like started, started. So if you build your detection in the lab, and then you just ship it to production and pray it works, in this case it will fail, right? So this is not that common. I think I've seen this only 3 times or something in the last couple of years. The casing thing is just always prevalent, super noisy. So again, don't trust the data to be consistent. Also understand the intricacies of your query language, right? So double equals is different than an equals tilde, because that is case insensitive versus case insensitive. This is not a Kusto thing. This is also in Elastic and all these other query languages. Really think about what you're trying to do. And sometimes a little bit less performance and better visibility is way better. And the differences aren't that big, in most environments at least. But also validate your detections in several environments. So if you have a lab, also have a test range and maybe a production range. And if you are lucky enough to have several clients to test it in multiple environments, because it can happen that the data looks slightly different because they're on a different tier of rollouts of a new schema or these kinds of things, which can be super annoying. And most of all, like an eye for detail is super important, right? So all the people with OCD are super happy about these kinds of things because they notice it. Sometimes it takes me also a while to figure it out. But these are kind of the things that are very important, right? So to wrap up, for me personally, it is like failing is a great teacher, because first and foremost, it teaches humility, right? I often get frustrated, maybe not crying. But I have opinions. So that's one of the ones, but also it sort of enforces me to dig deeper, to try to understand why something is happening, why something isn't happening, why I can or cannot see it. And you have to come up with sometimes a creative alternative, or rely on some help from outside to actually stimulate yourself, right? So in at least in a constructive way. So with that was it. If there's questions or opinions.
So you were showing the slides about how Defender looked like it was kind of throttling the logging of events for Kerberos and the network events. I think we can see why trying to save you, if you're paying by gigabyte of logs, trying to save you. Is there a way to modify that on the host and have it run? Does it get overwritten by the agent? Did you explore that?
Yes, we did explore that. So the config is pushed from the cloud to your machine. It is signed by Microsoft, so changing it will break the signature and it won't let you. Also, it's not the most accessible place. So they're changing this. So I think starting next month, they start rolling out these dynamic cappings. So then it's per machine. So if you have a very noisy machine, it will throttle down, but all the other ones will show you a little bit more. That's one fix they sort of are pushing. The other one is they started releasing aggregate reporting as a new feature, which you can enable. And basically what that will do, it will still throttle it down. So you will get one full event a day, but every hour you can see if there's like a repeat or something and a count of it. So you can see this happened again X many times. So you don't have a full blind spot. Right. You just don't get the full telemetry. So that's sort of their in the middle fix to show you that it happens, but they still save a lot of bandwidth. There won't be a way where you can define a full config.
Even with OAM policies, the Intunes maybe?
No.
No.
No, the only thing that they're now working as well is custom collection, which is a feature that will come at some point, where you can define Sysmon-like rules and get data in at your own expense.
Are you guys doing any of the RBA, and how do you go about setting up some of those correlated searches for some of that?
We are doing RBA, which is basically risk-based analytics, if I interpret the same abbreviation at least. Yeah, what we are doing is we built a custom engine to do that. Henry talked about that yesterday, actually, where we take it out and put it somewhere back in, either in Sentinel or in a separate database. The engine within Defender is not sufficient enough, same with Sentinel. So yeah, we built our own solution, technically.
Could you talk more about the life cycle of detections, like how you go back and refine them over time and kind of keep them up to date?
Great question. What we tend to do is we test all of our detections. The ones that we can automatically test, we have a pipeline that just detonates real attacks every period, so that we can see if it's still firing on the things that we expect it to do, these kinds of things. On top of that, we have a monthly maintenance cycle where we have a couple of automations that check for if we're using URLs in our documentation or in our rules, if they're still valid, if they're still providing the same responses we expect. But we'll also iteratively go through it, and also based on customer feedback, because we build usually detections for customers. We'll monitor how the rules are doing, so performance-wise, but also output-wise. How many false positives are there? Are there missed opportunities? Did they detect something with another solution that we should have done with our detection? All these kinds of things. So we have a monthly cycle and a quarterly cycle. And then based on any of these outputs, we can still choose to deprecate a rule or refine it.
So I was wondering, you said that you're replicating those tests. Are you using something like Atomic Red Team, or did y'all build something in-house?
Yeah, sorry, Ryan. We're using our own stuff, primarily because we want to control the whole end-to-end cycle. And additionally, I like Atomic Red Team. The things that we missed from it, we basically took their schema and extended it with expected triggers. So which detections do we expect to fire? And we also extended it with, we detonate an attack, but we also want to measure whether that attack succeeded. Because it could be that the policy blocked it, and it looks in the logs that we executed it, but if it fails, then my detection might also fail. So we have more ways to correlate it. But it's way more work, of course, because the community builds all these great scripts, and we just ignore them and build our own. It's not invented here, I guess. Yeah.
I think you said from the logs, you saw 30 counts, right? 30. In your lab, you replicated, you only got one. What did you I didn't get that part. Did you not set up the query correctly or casing, or can you explain again? I'm totally lost.
I was comparing two different solutions. So Sysmon is one solution where it showed me 30.
Yeah.
And I compared it to the EDR, which in this case was Defender for Endpoint. And with the same query, same time frame, I only see one, because they basically filtered their log output. So they only show you one event, assuming that the one is enough for your detection. But in research, then you see it only once and the rest is gone. So that's a limiting factor.
Okay, got it. Thanks.
Yeah, no problem.
Defender for Endpoint in particular has certain filters. Is there any documentation of like what they choose to filter out? Like, I know that I've heard that like certain registry things get filtered, but I've always wondered, like, is there anywhere you can go and look to figure that out, or is just poking and testing the only way to figure out what's exactly filtered?
There's no official documentation, nor will there ever be. I talk to the development team quite often, and they have several reasons not to do this. The first and foremost is they don't want to enable all the offensive people, which makes sense. Second reason is competitive advantage, which I think is bullshit. But I mean, it's a company that wants to earn money, right? So in some way, fine. I kind of like the elastic approach where they're just, okay, here's everything. They now even started doing a bug bounty on their detections. But now, yeah, so there's no official way of doing it. If you're a little bit creative and you poke through the registry, you might find something. On a Mac, it's way easier. It's just in plain text, and on Linux as well. So they still store it. It is accessible, and then with that, you can actually explain why it's so annoying. I started building a project that I probably will never open source, but I have a wiki where you can just go through it for internal use. But there won't be an official way of ever showing you that.
I noticed in your workflow, your team is not responsible for, say, defining what actions an analyst will take when the rule fires. Is that your team, or, is that another team's responsibility?
Good question. No, partially no. So what we do is we build the detection, we do all the documentation, we define the minimal follow-up steps that we think are necessary, and then we transfer it to usually our customers. And they basically build their playbooks around our guidance. So there's partial steps. So that's a good question, but not a complete playbook, because every organization has different procedures and methodologies and these kinds of things. So we give the right pointers, and then we usually have a follow-up meetings with the client to explain more what they should be doing about it if they're still in the know.
Thank you.
Thank you.
Thank you, Olaf, and give him a round of applause.
Thank you.